So for today, we're going to talk about basic integration of hyperbolic functions, and we must at least familiarize ourselves with the formulas involving hyperbolic functions. As we can see here, we have 8 formulas in integration of the basic integration of the hyperbolic functions. So, uh, I advise that you take a picture of this, or you take down notes in these formulas as we are going to solve some problems. Okay? And in integrals, we have so many formulas. That's why there is a different formula for the integration of trigonometric function. There is a different formula in hyperbolic function, and so on and so forth. We have so many formulas here in integral calculus. So, might as well you take note of these formulas. Okay? So, let's get started. Okay? So, let's start by integrating this problem. So, the integral of hyperbolic sine 1/2 x dx. As we can see here, okay, if we look at this formula, the integral of hyperbolic sine x dx is equivalent to the hyperbolic cosine of x plus c. Okay? There is no negative, whereas in trigonometric function, there should be a negative. But in hyperbolic function, there is no negative here. So, what we can see here is we cannot directly integrate this as hyperbolic cosine of 1/2 x plus c. Why? Because our formula only tells us that this is the hyperbolic sine of x dx only. Okay, so why we have to let u as 1/2 of x, okay, and du as 1/2 dx. Okay, so in other words, we will be using the u substitution here. Okay, so we have the du is 1/2 dx. This does not have a 1/2. Okay, so we're going to have a correction factor of 1/2, and of course the reciprocal of this correction factor outside of the integral sign. So we have 2 integral of sine hyperbolic sine of let u 1/2 x, and then we have 1/2 dx that is equivalent to du. Now we can integrate this function. This is also the same as sine of x, or hyperbolic sine of x. Okay, whereas our variable only here is u. Okay, so if we integrate that, that is 2 hyperbolic cosine of 1/2 x plus c. Okay, our u is actually, we replace it already by 1/2 x because originally our variable is in terms of x. So that is our answer. So for number 2, okay, we have a hyperbolic cosine of 2x dx. Okay. In this case, we will be also adding a correction factor of 2 inside of the integral, because if we let u as 2x, the derivative of 2x is 2 dx. So we have to have 2 dx here. And of course, if we multiply 2 inside of the integral, outside of the integral, we must multiply 1/2 here. So our answer here, if we're going to rewrite this by performing u substitution, 1/2 the integral of the hyperbolic cosine of u du, hyperbolic of cosine, okay, the integral of hyperbolic cosine is hyperbolic sine 2x plus c. Okay, so that's very simple. Okay, for number 3, we need to find the integral of hyperbolic secant squared of 2x minus 1, okay, dx. Okay, we will be also using u substitution here, in that we have to make u as 2x minus 1, the du is 2 dx, so that we will be getting a correction factor. We will be putting a correction factor again of 2 and 1/2 on the outside of the integral. So what will happen here is that we will be having 1/2 integral of hyperbolic secant squared u multiplied by du. And our formula for this is simply hyperbolic. The integral of hyperbolic secant squared u du is equivalent to hyperbolic tangent. So we have 1/2 hyperbolic tangent of 2x minus 1 plus c. Okay, I've already substituted the value of u, which is 2x minus 1, for our final answer. Okay, let's go now to number 4. It's pretty easy, right? Because this is a basic video all about integrating hyperbolic functions. So we have the integral of hyperbolic secant x dx. Okay? This is a tricky one. Okay? If we rewrite this hyperbolic secant, we have 1 over hyperbolic cosine of x dx. Okay? That's a identity in hyperbolic functions. Okay. So, what will happen here is if I'm going to add a hyperbolic cosine of x in the numerator over hyperbolic cosine squared x dx. Here, this integrand is equal to this because cosine, hyperbolic cosine of x divided by hyperbolic cosine of x squared is still 1 over hyperbolic cosine of x. Okay? And we must take note that there is an important identity involving hyperbolic function wherein we have this identity. Okay? Wherein we have hyperbolic cosine of x squared minus hyperbolic sine of x squared is equal to 1. So if I'm going to replace hyperbolic cosine of x squared here, okay, what will happen is that I will be having hyperbolic cosine of x over 1 plus hyperbolic sine squared of x here. Okay? Dx because of this relationship or identity. So as if I'm going to transpose this on the other side, I'll be getting this formula. Okay? So, and again, we can what? This is a little bit tricky because if we have this, if we write this integral in the form of this, okay, 1 squared plus hyperbolic sine squared. Okay? This is hyperbolic sine squared. I'm so sorry. This is hyperbolic. Okay? Of x. Okay? We can see here, we have a dx here. We can see here that this is an integral yielding to an inverse trigonometric function. So, it is in the form of, let's say, we have, it is in the form of dx over 1 plus, okay, u squared, or this is a squared, okay? And this integral is actually yielding to an inverse 1 over a, okay, let me just rewrite this. So for you to get it. So what I'm trying to say is if we have an integral of dx over a squared plus u squared, okay, that is an integral yielding to arctan 1 over a arctan of x over a plus c, which is, we're going to analyze, this is our a, okay, and this is our u. I'm sorry, this should not have a squared here, but rather we have hyperbolic sign squared here. We factor out the square sign, okay, but this is still equal to this. So this is our u, this is our a. So if we're going to put it into this form, okay, if we're going to let u here as hyperbolic sine of x, going to get the derivative of hyperbolic sine, that is hyperbolic cosine of x dx, which is available here in our numerator, we can perform therefore this. So what will happen is that we have 1 over, our a is 1 arctan of x. What is our x? Okay, or I mean this would be u, okay? So hyperbolic sine of x over a, which is 1 plus c. And if we're going to simplify this, we'll be having arctan of the hyperbolic sine of x plus c. So this should be our answer to our problem. So my mistake, this should be u if I'm going to use u. Doesn't matter if you use x here, then definitely this would be x. Okay? But in our formula, I used u so that this would be also u and not x. Okay? Okay, let's proceed. But before proceeding, it's also important to take note that hyperbolic sine of x is equal to the following: e raised to x minus e raised to negative x over 2. And we have the hyperbolic cosine of x is e raised to x plus e raised to negative x over 2. Okay? So, we need this for our fifth example. So we have number 5, the integral of e raised to x hyperbolic cosine of x dx. So if you learned already integration by parts, you can perform integration by parts. But what I would like to share with you here in our video is that we're going to replace hyperbolic cosine of x by this, okay? And evaluate the integral. So what will happen? We have integral of e raised to x multiplied by e raised to x plus e raised to negative x over 2 dx. So if I'm going to multiply this, what will happen? We have e raised to x multiplied by e raised to x, okay, over 2 dx plus integral of e raised to x multiplied by e raised to negative x over 2 dx. I've already used the property of integral wherein we can distribute dx and as well as the integral sign. So by loss of exponent, these two would become e raised to 2x over 2 integral dx plus e raised to x. So e raised to x multiplied by e raised to negative x. So their exponents would subtract, and x minus x is e raised to 0 over 2 dx. So we are left with e raised to 2x over 2 dx plus any number raised to 0 is 1 half dx. So that we can now integrate this. So we have 1 half e raised to 2x plus 1 half integral of dx. I've put the constant outside of the integral sign. So we have the integral of this should be 1 half multiplied by 1 half. You see, you will have to use u substitution here. And if you get the derivative of 2x, that is 2 dx. Okay, forgot the dx here. So 2 dx, then you have to have a correction factor of 1 half outside of the integral because the derivative of this is 2. So 1 half times 1 half, okay, copy the same, okay, e raised to 2x, oops, so we have e raised to 2x, then plus 1 half integral of dx is x plus c. So we have now 1/4 e raised to 2x plus 1 half x plus c. And we have now our answer for this problem. So for our next problem, we'll be having this problem. So we have number 6, the integral of x hyperbolic sine of x dx. Okay? So we'll be using again the substitution of hyperbolic sine of x, the definition of hyperbolic sine of x, which is this: e raised to x minus e raised to negative x over 2. So, if we substitute that, we have integral of x multiplied by e raised to x minus e raised to negative, we have negative x over 2 and dx. So if I'm going to distribute the x in our function here, so we have x e raised to x minus x e raised to negative x over 2 dx. Okay, I can separate those two, wherein I will be having x integral of x e raised to x over 2 minus dx minus the integral of x e raised to negative x over 2 and dx. Okay, so what will I do to simplify the integral is I have to let the 1 half outside of the integral sign. Okay, so that I have x e raised to negative x dx minus 1 half the integral of x e raised to negative x dx. Okay, and I can perform integration by parts here. I'm going to let u as x. My du would be dx, okay? And my dv here would be e raised to x dx, and our v is simply e raised to x. The same here, let u as x, our d would be dx, and my dv would be e raised to negative x dx, and my v, if I'm going to integrate this, I would be having a negative because this is a negative e raised to negative x. So negative e raised to negative x, okay? That would be my uh, parameters, okay? So what will happen here? Again, we're going to perform integration by parts. Okay, if I'm going to perform integration by parts, recall that the formula is uv minus the integral of v du. So I have 1 half, okay, uv for the first, I have u x, okay, I have the x multiplied by v, e raised to x minus the integral of v, e raised to x, my du is dx, okay, minus 1 half, okay, uv x multiplied by negative x e raised to negative x, because here is our u and our v is negative, so that we have this product, minus the integral of v du. Our v du is negative e raised to negative x, and my du is equal to dx simply. Okay? So what will happen is that 1 half, okay, x e raised to x, if I'm going to integrate this, what will happen? I'll be having 1 half also e raised to x here. Okay? If I'm going to distribute this, we'll be having plus 1 half x e raised to negative x. And we have, if I'm going to factor out negative here, negative times negative, because this is a minus sign, that would be positive. Okay? And multiplied by negative, so I will be having negative 1 half integral of e raised to negative x. Okay? So, 1 half of x e raised to x minus 1 half e raised to x plus 1 half x e raised to negative x minus, okay, if I'm going to integrate this, okay, if I'm going to integrate this, it would produce a negative e raised to negative x multiplied by a negative, that would be positive 1 half e raised to negative x. Okay? So, what will happen here? If I'm going, well, of course, we have the plus c, okay? If I'm going to rearrange this, okay, such that I'll be picking 1 half x e raised to x, and I have here another one, plus 1 half x e raised to negative x, and minus 1 half e raised to x, this is that term, plus 1 half e raised to negative x plus c. And if I'm going to factor out x in this term, okay, x in these terms, I'll be having this, okay? X would now be x, or sorry, e raised to x. So e raised to x, okay, plus e raised to negative x over 2, okay? Minus, if I'm going to factor out the negative here, we would be having what? We would be having e raised to x minus e raised to negative x over 2 plus c. And if we are going to recall, this whole term is equal to hyperbolic cosine of x, and this whole term is equal to hyperbolic sine of x by definition. So would be the answer would be x hyperbolic cosine of x minus, right? Minus hyperbolic sine of x. Hyperbolic sine of x plus c. So that is the integral. That is our answer for that integral. And if you're going to do integration by parts from the very beginning here, okay, you'll be arriving at this answer. I've just shown you that this function can be used also if we are going to integrate, and it would yield to the same answer. Okay, down to our last example for this video. So we have number 7, if I'm not mistaken. We need to find the integral of the x squared multiplied by the hyperbolic sine of x dx. Okay? So let's try to use, integration by parts here. Okay? So if we're going to let u equal to x squared, du is 2x dx. And our dv is what we have left out, is hyperbolic sine of x dx. And if we're going to integrate this would be hyperbolic cosine of x. Okay? And applying the formula we have, okay, we have uv. Our uv is x squared hyperbolic cosine of x, okay, minus the integral of v hyperbolic cosine of x du is our 2x dx here. Okay, and if I'm going to further solve this, what will happen, I can factor out 2 outside of the integral sign because that is a multiplication. So I have x hyperbolic of cosine of x dx here. Okay, and this is again an integral yielding to another integral. So we have to let another IDT, I mean. We have to let u is equals to x, du is equal to dx. Our dv again is hyperbolic cosine of x, and our v is hyperbolic sine of x. Okay? So what will happen? Apply again the formula. We have x squared hyperbolic cosine of x minus 2, okay? uv, we have u, x hyperbolic sine of x minus the integral of v du. Hyperbolic sine of x, our du is equal to dx. Okay? So we have x squared hyperbolic cosine of x. Distribute, we have negative 2x hyperbolic sine of x. Distribute also the integral of the hyperbolic sine of x is simply hyperbolic cosine of x. If I'm going to distribute this negative 2 with the negative, that would be positive 2. And the integral of this is hyperbolic cosine of x. Don't forget the plus c, of course. And as you can see here, we can factor out cosine or hyperbolic cosine of x by, we have hyperbolic cosine, oops, we have hyperbolic cosine of x is multiplied by x squared plus 2. Okay, this is that term and this term minus 2x hyperbolic sine of x, okay, plus c. So this should be our answer for our problem here. And thank you so much for listening. Thank you so much. This is only a basic integration involving hyperbolic functions. And I hope you guys learned a lot. And if you like this video, please don't forget to leave a thumbs up and comment down below. And please subscribe to my channel for many or for upcoming integral calculus videos. So thank you so much and God bless you.